how machines actually make decisions, how they seem to just instantly know things. Well, get comfortable, because today we're pulling back the curtain on the magic of machine classification.
Think about this for a second. Imagine opening your email, and your app just already knows which emails are annoying spam and which ones are actually important. Or think about when you pick up your phone, and it instantly unlocks just by seeing your face. It's so seamless, we completely take it for granted. But how does your inbox actually know? How does your phone know it's you and not some random stranger? Well, it's not magic. It's classification and machine learning. And by the end of this explainer, you're going to know exactly how it all works.
So here is our roadmap for today. We'll be hitting 1. What is classification? 2. Types of classification. 3. The project workflow. 4. Algorithm study guide. 5. Challenges. And 6. Real-world impact.
All right, kicking things off with Section 1. What is classification? Sorting the world.
So in the whole world of supervised machine learning, there are basically two main paths you can take. You can predict numbers, like forecasting tomorrow's temperature or, estimating the future price of a house, but that is not what we're looking at today. Classification is entirely about predicting categories, or what we call classes. Instead of giving you a number, the machine is trained on labeled data to answer questions like, is this email spam or not spam? Is this credit card swipe fraud or legitimate? Is this picture a cat or a dog? Or is this medical test disease positive or negative? It's literally just about putting data into the correct bucket.
Moving right along to Section 2, Types of Classification, Bins and Labels.
Okay, so there are 3 main ways this plays out in the real world. First up, we have binary classification. This is the absolute simplest form. You only have 2 possible classes, yes or no, true or false, pass or fail. Next, we step it up a notch to multi-class classification. This is when you have more than 2 distinct classes, but the final answer is still just one of them. For example, sorting an animal image into a cat, dog, or horse, or maybe recognizing handwritten digits from 0 to 9. And finally, we have multi-label classification. This one's pretty cool. It's where one single item can belong to multiple categories simultaneously. Think about how Netflix classifies movies. A single film can be action, comedy, and sci-fi, all at the exact same time.
Which brings us to Section 3, the project workflow, behind the curtain.
Teaching a machine is remarkably similar to teaching a kid, and it basically happens in 4 fundamental steps. Step 1, collect data. If you want to build a spam filter, you have to gather thousands of emails that are already manually labeled as spam or not spam. Step 2, train the model. The algorithm looks at all this data and starts learning the patterns. It notices, hey, spam emails constantly use words like free or win. Step 3 is prediction. A brand new, unseen email arrives, and the model applies what it learned to predict if it's spam or not. And step 4 is evaluation. Basically, we grade the model's homework to measure exactly how accurate its predictions actually were.
Now, if you're out there working in the industry using popular tools like scikit-learn or TensorFlow, that basic 4-step process expands into a full 7-step professional project cycle. Before you train anything, you have data cleaning, fixing all the messy or missing info. Then comes feature engineering, which is highlighting the most important parts of the data. You do a train-test split so you have fresh, untouched data to test the model on later. After model training and evaluation, you finally reach deployment. Deployment is the grand finale. It's pushing that model out into the real world, like integrating it into your actual phone or email app. It's the full journey from cleaning data to model deployment.
All right, let's jump to Section 4, Algorithm Study Guide. Meet the models.
I want to give you a quick summary, a rapid-fire tour of the different algorithms data scientists use to build these tools. First, logistic regression. It uses simple probability and, despite the fancy name, it's incredibly fast for making binary decisions. Next to decision tree. This works exactly like a flowchart. It asks questions like, is age greater than 18, making it super easy to visually understand. Then, a random forest takes that a step further. It's essentially a collection of trees voting together, like a highly nerdy council of experts, which gives it high accuracy for complex stuff in finance and healthcare. Next is SVM, or support vector machine. This method finds patterns by drawing the absolute best boundary line to separate classes, perfect for complex data. KNN, or K-nearest neighbors, also finds patterns, but simply by looking at nearby points. It's like saying, if all the fruits near this one are apples, well, this is probably an apple too. And finally, naive Bayes. Based on probability, this is the ultra-fast engine typically running behind text classification and spam filtering.
Time for Section 5, Evaluation and Challenges, when things go wrong.
So, first off, we have to keep score. We can't just ask if a model is good.
We use precise evaluation metrics for model performance tracking. Common ones like accuracy, precision, recall, and the F1 score are the strict mathematical rulers we use to measure exactly how well our model is predicting the right labels. But look, even with good scores, hidden traps are everywhere. For example, think about a classic trap called data imbalance. Imagine you're building a fraud detection model for a bank. Now, in the real world, 99% of transactions are totally normal, and maybe only 1% are actual fraud. If the model just lazily guesses not fraud every single time, well, it's technically 99% accurate, but it completely failed its actual job. The machine becomes totally biased toward the majority class if we don't catch and manage this imbalance.
And then we have the twin headaches of overfitting and underfitting. Overfitting is when the model basically just memorizes the training data. It's like a student memorizing the exact answers to a practice test, but then failing the real exam because they didn't actually learn the underlying concepts. Underfitting is the exact opposite. The model is just too simple. It's like a student who barely studied at all and can't grasp any real relationships. Navigating between these two extremes is literally the true art of machine learning.
Bringing us to our final section, Section 6, Real-World Business Impact, Classification in Action.
You guys, the models we just discussed are quite literally powering the modern world. In medical AI, classification models are assisting doctors with medical diagnosis, detecting whether scans show cancer or if a test is COVID positive. In finance, they are vastly improving business decisions by instantly handling loan approval processes and spotting credit card fraud. They're the backbone of cybersecurity. They help self-driving cars classify a stop sign versus a pedestrian. They power your voice assistants, and they perform everyday tasks like social media content moderation, tirelessly filtering out toxic comments. Almost every AI product you interact with relies on classification somewhere in its DNA.
And that brings us to our core takeaway for today. From spam filters to disease detection, classification helps machines make decisions by assigning labels. It's absolutely one of the most powerful foundational techniques in all of machine learning. By simply sorting the world into neat mathematical bins, machines can make incredibly complex, lightning-fast decisions that improve our daily lives. Which leaves us with one final, kind of wild thought to walk away with. As you go about your day today, scrolling your feed, swiping your card at the store, walking past security cameras, just ask yourself, what is AI classifying about you right now? Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I'll catch you in the next one.